Hi, so I'm just holding my phone, so it's not going to be the best quality of video. So what I'm doing here is I'm running through question 14b in mixed practice exercise 8, and it's on rotation. It's obviously volumes of revolution, and I know Ms. Hoyle did this with you because she needed it for mechanics, I think. Right, so what I've got here is a question that you might have done in normal maths, and I just want to use, I think this is quite a good way of explaining why question 14b is so difficult. If I wanted to find the area, so what I've got here is the curve y equals sine x and y equals cos x, and you can see that they intersect. Now, if I wanted to find this shaded region, okay, so bear with me because I know it's a bit handheld. If I wanted to find that shaded region, the only way I could do it is two separate integrals. So what I would do is I would think of that as region A. So I would need to find where sine x meets cos x. And of course, you know how to solve that. That would just be a year 12 question. You would divide both sides by cos x and you would get tan x equals 1. So you know that they would intersect at pi by 4. So the only way you could do this question is by two separate integrals. You would integrate sine x with respect to x between pi by 4 and 0. And then you would integrate your second curve, cos x. And again, this time your limits would be between pi by 2 and pi by 4. So that's the only way that you can actually do that question. So we're going to continue with that idea. So this is me now going to the textbook. So this would be considered quite a hard question because it's around the y-axis. And whenever you rotate around the y-axis, it does raise the level of difficulty, and that's good because you'll be given more credit for it. So in either way, it would be more marks or it would be lower grade boundaries. So that's why it's quite a challenging question. So what you're going to have to do is, and the only way you can do it, because it's two curves and it's not, you're not one take away the other. So you are literally, so part A gets you to work out, well, it tells you. So part A is to show that. That's not what we're looking at, because that's just, quite straightforward, sort of log work, year 12. But part A has told you that they meet when x is e and y is 1. So you are literally going to split it into two at the line y equals 1. And you're going to rotate above y equals 1 separately around the y-axis, and you're going to rotate what's below y equals 1 separately around the y-axis. So here is my solution, and it's going to be one of those rather crude ones where I just unveil it. So this is okay. So first of all, I took the curve y equals minus 1 over ex plus 2, and I know that that's got y limits between 2 and 1. And I know that when I rotate around the y-axis, I use that formula. Okay, so the first thing I'm going to do is I'm going to rearrange my equation to make x the subject. So again, that's quite straightforward. And that minus e looks a bit of a pain, but I know that e is a constant, and obviously if I square minus e, I get a much nicer positive e squared. So my x squared is actually something that's kind of neat. And what I really like about my x squared is that it can come outside the integral because it's a constant. So then I just integrate my y minus 2 all squared, and obviously I'm using reverse chain rule there. And so rather than writing, I really like constants outside my square brackets. So I've then integrated it, again, normal maths. I substitute my limits in. I am mindful that it's a show that question. So I've substituted my limits in, and I end up with a really kind of neat a third pi e squared. Okay, so then, hang on. I then go to the part of the bit below that line, y equals 1. And obviously what I'm looking at here is the graph y is ln x. And this is the portion that I need to rotate around the y-axis. So you can see that I'm writing it all out. So again, I've got my formula. I can see this time my limits are between 1 and 0. And this is something you should be familiar with in your normal maths. Obviously, if y equals ln x, you know that x is e to the y. So x squared, obviously e to the y, all squared is e to the 2y. So I then go into my formula. Okay, and I'm going to integrate that with respect to y. Again, I'm going to take that half outside because in my head, especially for detailed reasoning, I personally think it's easier. Feel free to disagree with me. And then I've substituted my limits in, and of course I know that e to the 0 is 1. I'm mindful that this does need to be an exact answer. So as you can see here, the volume of my shaded region is A plus B, my two regions. So I literally add my answers together, and you can so you can see I've written that out. And obviously they would expect you to simplify it. And you can see I've fallen at the last hurdle. When I wrote that out, I was so busy adding a third and a half together to get 5, 6, that when I wrote it out the first time, that minus pi by 2, it just became a plus. And luckily I spotted it. And then I took out a factor of pi. You're really good at taking out factors. So if you wanted to, you could take out a factor of pi over 6. And obviously that would then leave you 5e squared minus 3 in there. But I then looked, and that's the answer that they've got there. So I hope that makes sense.